All right, class. Well, this is take 2. I totally presented this entire thing and it wasn't recording. So, sorry. Let me tell you what, I'll put a question about this on the quiz. It should be pretty easy to get. All right, let me go through this. The periodic table is set up in a very organized fashion. There is nothing random about it. Each element that is found in nature and those elements that have been synthesized by man are located on the periodic table. You'll notice that it's put together according to atomic number 1, 2, 3, 4, 5 through 10, 11 through 18. You'll keep seeing this working out until you get to 57, and then it jumps to 72. I want you to notice that 57, jump down here, 58 through 71, then it would pick up as 72. The element 57 is called lanthanum, so we call this set of elements the lanthanides. When you get to the next row, you can see that 89 jumps to 104. Well, 89, then here's 90 through 103. Okay, and so we call these, because the last one before it on 89 is actinium, we're going to call these the actinides. If you want to remember how to keep these straight, there's a city in California called L.A. Okay, L is first over A, so lanthanides and actinides. All right, let's go ahead and start numbering some things. The periodic table is divided into columns and rows. The columns are called groups or families. They are, let's number them, 1, 2, 3, 4, 5. You're going to go all the way to 12. Okay, then you go back up and finish up at 18. There are 18 groups or families. Groups tell us something pretty important here, and we'll share it with you in a minute, but the group number is a column. Another term for a group is a family. All right, going down the side here, you have periods. They're the rows. 1, 2. Go all the way to 7. These are your periods, and they are just the rows. So what they do is they number the columns, they number the rows. It makes things a lot easier. I am going to tell you that the period number is going to give you the number of energy levels that those atoms have. Let me explain that to you. Every element in the first row, hydrogen and helium, is going to have only one energy level. Every element in period 2, the second row, they will all have 2 energy levels. 3, and so on. That's how that's going to work. Now, there is a quick way to figure out the charge of an atom and the number of valence electrons by looking at the group number. The valence electrons are going to be determined by what group an atom is in. So valence, I'm going to put an E- for electrons. Every element in group 1 will have 1 valence electron. Every element in group 2 will have 2. Now we have to be very careful about groups 3 through 12 because they don't really have a pattern, because they're called the transition metals or the transition elements. So this little quick shortcut I'm showing you right now does not pertain to groups 3 through 12, but it does pick back up at 13. Every element in group 13 has 3 valence electrons, 14 has 4, 15 has 5. You can see the pattern here. 16 has 6, 7, and 8, except you do have one little exception here, and that's going to be your helium. Helium cannot have 8 valence electrons. It only has 2 electrons in total. But what works beautifully here and makes it to where it fits there fits in this group is that these are all called noble gases, and they're all stable. Okay, with all of that said, let's go ahead and start looking at the charges. That if ions were to be created out of these elements in certain groups, we can figure out what charge they would have. If an atom has 1 valence electron, that means it's going to be the easiest thing to lose that 1 electron. If you remember, if you lose one positive or one negative out of your life, you're going to be left with one positive. If you have 2 valence electrons and throw out 2 negatives, you're left to be 2 positive. Okay, what this is meaning is that if you were to have an ion of any element in group 1, it's going to have a +1 or a 1+ charge. Group 2 is going to have the 2+. Now skip 3 through 12. It's just as the same as valence electrons. You cannot figure out the charge by a pattern. Group 13 will all end up to be 3 pluses. Let's go to 14. I want you guys to think about this. Because of the octet rule, 8 valence electrons is considered stable, even if the energy level has room to hold more. 4 valence electrons is right in the middle of 8. So it's just as easy to lose electrons as it is to gain them. But I want to remind you, we also talked about the option of them sharing. Group 15 has 5 valence electrons. To get to 8, it is way easier to bring in 3 negatives to get to 8. Group 16 will bring in 2 negatives. These negatives are your electrons, of course. 17 will bring in 1 negative. And 18 is not going to do anything because it is a noble gas. Let's go ahead and label the groups as they are. Okay, the first column, these are the alkali metals.